Let us look at special case, which is function who is involving logarithm. Why this one is special? Because logarithm we have some special rules, which is the logarithm rules of logarithm. So the first one of the rule of logarithm is when I have an ln pq, I can rewrite as an ln p plus ln q. Then the second one is ln p divided by q, I can rewrite as ln p minus ln q. Then the third one will be when I have an ln power of q, actually is q ln p. And then one more thing that is, please remember, we have, if I have an ln exponent of 2x, so I'm going to have 2x because ln and exponent, they are inverse of each other, so they will be giving you 2x. So these special cases are based on these few rules for the logarithm. So now, if I using these rules applying for this question, my y will be can separated as an ln p e 2x minus ln 5 plus ln x. Okay, so after that, my y actually, because of ln e 2x, I can rewrite as a 2x, so minus ln 5 minus ln x. So now I differentiate, I will get 2 minus 1 over x. So now I already solved this question. But how about if you have the difficulties to remember these rules while exam or doing the practice, don't worry, you still can use the differentiation of the logarithm using the chain rule. So now my question is y equals to ln e2x over 5x. So first thing, we will be recopy whatever inside the ln at the denominator. So e2x over 5x. And now how you're going to facing the problem is because you need to differentiate e2x over 5x. So you need the uh, product rule. So differentiation of e2x over 5x. So my u actually is e2x. My v is 5x. So u prime is 2e2x. My v prime is 5. So by applying the formula using uv will become v squared vu prime minus uv prime. So my v squared will become 5x squared, and then 5x multiplied with 2 e2x minus 5ex, and we factor out the common factor. So over here is 5ex, and then I will have ex minus 1 over 5x power of 2. Now I copy this one replacing over here. One more thing that is for this, if you're using this particular thing, that is you need to recall the algebraic, that is when you have 3 over p over q, it will become 3q over p. So you need this thing. So I flip over here. So I will be having 5x over exponent 2x. I multiply with the one differentiate from here. So I have a 5ex. Then I have 2x minus 1 over 5x squared. So now I'm going to cancel off all the thing that which is similar. So this one, and then this one when I cancel here. So finally this 5 I cancel here. So finally I have a 2x minus 1 divided by x. If I keep on simplifying, I have a 2 minus 1 over x. So this one is exactly look like this. Okay, now maybe when now at this moment you were just thinking that is, if you are not applying the rules of a logarithm, you'll be having a very long lengthy working. Yes, it's true. So that's why the rules of logarithm is useful for the differentiation, because the purpose of this logarithm, rules of a logarithm, is helping you to reduce your working. Now, example, this one actually is even more special compared to the previous question, but they are still the same, that is using the logarithm. Okay, for this question, if you look at here, over here there is a product of two different function, and then you're going to be having a quotient with another one function. So this question, they are not hoping you to use any product or the quotient rule. What they're expecting you to do is you take the, okay, by taking both sides having the logarithm, natural logarithm ln y, and then you're taking ln, so you're going to have a x plus 1 divided by x squared minus 1, and the whole thing of this one power of half. By applying the four rules before this, over here, this one I can bring in front, 1 over 2 ln. I separate it, will become ex plus ln x plus 1 and minus x squared minus 1. So now I can differentiate. This one is an implicit. Differentiate ln is 1 over y dy dx, and then half differentiate. Actually, this one I can write as an x. So I differentiate x, actually is 1, and this one is x plus 1, 1, and finally this one is x squared minus 1 and 2x. And now if the question looking for dy dx, so I need to bring my y up. So 1 over 2y, this one recopy, then minus x squared minus 1, settle. If you use the normal method, which is using product rule and quotient rule, your work will be very, very long. So this one really is a special case, which is they are using the logarithm to help you to solve the problem. Now, so we finish up all the chapter 6. So we go through quickly few examples that is going to help you to do all the revision. Okay. Now the first question is, when we have y equals to exponent ax squared plus bx, we don't care, actually we don't care how complicated is the exponent or the power over here, as long as it's an exponent. So now first thing, recall back is when you want to differentiate exponent. So first thing, copy ax squared plus bx without doing anything. So keep it as it is. And then we differentiate ax squared, actually is 2ax. And differentiate bx actually is b. So this one we bracket out. So this will be your final answer. Now, and then for this question B, y equals to ln x over 2. It seems like a quotient, but the thing is, you remember that is the denominator 2. 2 is a constant, which is we didn't treat that is an is a function. So means I can factor out my 2 is 1 over 2 ln x. So when I differentiate, I only need to differentiate this ln. So differentiate ln is 1 over x. But now, as from my experience, that is some of you were still using this one, treating this one as an u over v. So there is no problem. So you keep on your work. That is, your u will become ln x. Your v equals to 2. So when you differentiate, you differentiate your prime is 1 over x. Differentiate 2 actually is 0. So you still can using v square, vu prime minus uv prime. So v square actually is 4. vu prime is 2 over x, and then minus 0. Okay, uv prime is 0. So now if you check over here, this one is 1 over 2x, is exactly the same answer as the previous one. So now, is it wrong that you use the quotient rule? No. But the thing is, when you compare with your friends using the normal differentiation of the logarithm, just factoring out the 1 over 2, your work will be slightly longer compared to them only. So there is nothing wrong. Now we look at this question. When we look at the question involving logarithm, excuse me, if you look at the left hand side and the right hand side, there's no difference on that is, so this one actually is involving the quotient of the logarithm, and this one is the multiple of the logarithm. So what you need to do when the logarithm, I can applying the rules is ln x minus ln 4x minus 1. Remember, half square root actually is half, so I bring my half in front, so half ln 4x minus 1. So I differentiate 1 over x minus 1 over then 4x minus 1, and differentiate 4x minus 1 is 4, so I cancel. So finally it's 1 over x minus 4x minus 1. Settle. So for this one, it's the same, almost the same as the left hand side. So my y is ln x plus ln half 1 plus x squared. So differentiate y prime is 1 over x tambah plus 1 over 2, 1 plus x squared, then 2x. So finally is 1 over x plus 1, 1 plus x squared. Okay, settled. Now, how about this question? So this question, if you notice that is, in between x cubed and the third x, actually is a minus. So there is no such rules that can let you to separate them. So don't panic. If they can't be separate, don't separate it. Just do as normal, which is y prime. Whatever inside the ln, you copy at the denominator. After that, differentiate x cubed is 3x squared, and differentiate this one, okay, differentiate so x actually is differentiate x power of half, so it's half x minus 1 over 2, so half x 1 over 2. So do you need to make this one as a in the denominator? No need, just keep it as it is. The question didn't ask you to keep your answer as a positive index. Now we look at this one. Okay, this one actually is a purposely designed to make you confused. If you look at the E2 over here, E2 is a number, it's a constant. It is not a function. So means you only need to be E2, change the x become power of half. So your y prime will become E2 half x minus 1 over 2. Settled. Because remember, E2 is a constant. Uh, the one is a function actually is E2x. When E2x, that means you have a function x. Then this one is E2, there is no x, means it's a constant. Now, how about this one? So easily, I can change it to become ln E2x minus ln 5x. Remember this one we tried before. When I have an ln EP, so it will become a p. So this one is y equals to 2x minus 5, minus ln 5x. So finally, prime 2 minus 5x over 5. This one cancel. So you will have 2 minus 1 over x. How about this one? Okay, this question, if you want to use u over v, proceed. But the thing is, the proper way or the actual way or the means is the better way to solve this question. Actually, we try to simplify this one. Why we can simplify this function? Because the denominator is x only, so I only need to divide. I spread them to become x cubed divided by x. I factored out the 1 over 2, so plus 2x4 divided by x, there's 2, and then minus 1 over x. So finally, my y is 1 over 2. X cubed divided by x actually is x squared. X4 divided by x cubed actually is 2x cubed. And then this one is x minus 1. So I bring the x going up. So my index is become negative 1. So now I differentiate. So 1 over 2, 2x plus 6x squared plus x minus 2. Settled. Okay. Now, how about this one? Okay, if you look at this question, you have two ways to solve it. One way is you rewrite, okay? So means that you have a set x plus set y equals to set a. So your set y equals to set a minus set x, and then your y is become set a minus set x squared. And over here, what you need to do, dy dx equals to 2. Bring this one down. And then set a minus set x. After that, you differentiate set a is 0. Differentiate this one actually is minus 1 over 2. X minus 1 over 2. Okay, so since this one can cancel, so I will have the 1 over set x, set a minus set x. Okay, or from here you can expand it. Y equals to set a, you become a minus a plus x minus 2 set ax. So your dy dx is equals to, differentiate a is 0, differentiate x is 1, minus 2. Okay, actually set. Okay, before that, I think I need to change this one to become a index first. So y equals to a plus x minus 2 set a x power of half. So now y prime, differentiate a is 0, differentiate x is 1, then this one 2 multiply 1 over 2, and then I have my set a, and then differentiate this one actually is 1 over set x. Okay, so finally I will have this one cancel, 1 minus set a over set x. Okay, now then you may say that is why these two look so different. But the thing is, when you are multiplied in, you will know that is they are similar. Okay, one thing that is maybe for this one, you need to check. Okay, you need to check whether I have some problem. I have a certain mistake on the sign. Okay, okay. Or then, if you don't like to rearrange this one, you can proceed from here by using implicit differentiation. So so I will change my question to become x half plus y half equals to set A. Why I don't bother this set A? Because set A is a constant, so it's going to disappear. So when I differentiate this one, 1 over 2 x negative 1 over 2. And then this one is 1 over 2 y negative 1 over 2, and dy dx here is become a 0. So I rearrange is dy dx. Okay, so this one I shifted here is minus x1 over 2, and then going to divide it by y negative 1 over 2. So, and if I flip back, this one will become set y over set x, that is a negative. So this one even look more different compared to what we have. Okay, now I remember, so this one there is a negative, so these two answers are the same. Okay, so now that's why this one, why it looks so different. If you want, you can substitute this one inside here, so you will have the same answer at the left hand side. So this type of question, which is an implicit question, but the thing is we can solve this one by using rearrange the equation, become an explicit, so you can differentiate it maybe you can say it's easier, but the thing is, no harm that is you can practice your implicit differentiation. Now, but this question, if you look at it, uh, it's maybe you can say, I can say that it is possible you can take ln left and right, but the thing is it is going to helping you or not? I'm not so sure. Okay, so now, one thing that is, because you learn about ln, maybe some of you will have want to some practice on it. Okay, so means that if you take ln left hand side, x plus y equals to ln xy. So the left hand side will become x plus y, the right hand side will become ln x plus ln y. So I can differentiate it. 1 plus dy dx equals to 1 over x plus 1 over y dy dx. I need to gather my dy dx. So 1 minus 1 over y equals to 1 over x minus 1. So my dy dx finally is 1 over x minus 1 over 1 minus 1 over y. And please rearrange this one. Reason is there is not a norm way to write a fraction. So this one is 1 minus x over multiplied with y, and then this one will become y minus 1x. Okay, you can practice this one, how to get this one on the final answer. Okay, but the thing is, normally we don't do this practice, which is taking ln, so we can directly differentiate this one. And remember, here is an y, this one is an x, so this one you need a quotient rule, product rule. So my u is equals to x, my v is y, so my u prime is 1, my v prime is dy dx. So this one is uv prime plus vu prime. So I'm going to have this one, first thing, exponent, copy back, and then differentiate the one top is 1 plus dy dx, and then equal this one, I copy back, u dv x dy dx plus y. And of course, I need to rearrange. So ex plus y plus ex plus y dy dx equals to x dy dx plus y. So I gathered dy dx ex plus y minus x equals to y minus e plus y, and finally dy dx equals to y minus ex plus y over ex plus y minus x. If you look at the left hand side and the right hand side, totally different, of course, because the approach we are using are totally different. But is it any chance that you will have a similar answer? Yeah, if you want to try to taking logarithm and make your exponent become a normal, so you will get the similar answer. Okay, now we go for the one of the question involving second order or differentiation. So if you remember here, this one is uv. So now when I want to start, I will start by u equals to x. My v is ln x. So u prime is 1, v prime is 1 over x. So my dy dx equals to xv prime. So x 1 over x minus plus ln x. So this one cancel. So I have 1 plus ln x. I need to differentiate the second time. So d square y and dx square. Differentiate 1 is 0. Differentiate ln x is 1 over x. Then how about this one? Differentiate one time. Exponent, remember our exponent, first thing, copy back, and then differentiate x cubed actually is 3x squared. Now, if you look at it, compared to the previous question, when first I need to use the product rule, and then after simplify, I don't need the product rule anymore. But the thing contrarily to this example, which is at the beginning, I never use product rule, but because after the first derivation, I need the second when I go for the second order derivation, I need to use the product rule. So now my u, I take 3x squared. My v is ex cubed. So u prime 6x. V prime is 3x squared ex cubed. So my d squared y dx squared is uv prime. So it's 9x4 ex3 plus 6x ex3. If you're interested, you always can factor out the common factor, 3x ex3. So the first one balance is 3x cubed, and then the second one balance is 2. So settled. Now evaluate y prime at the given value. Okay, so now y equals to this one. Okay, if the first thing before I want to evaluate this question, first thing we need to find the y prime. So if you see that is x and ex, so means that I need to u equals to x, v equals to e to x. So u prime equals to 1, v prime equals to 2 e to x. So y prime differentiate x squared is 2x minus uv prime is 2 e to x and then plus e to x. Okay, now do you need to means that do you need to simplify or anything? No need, because the question say you need to evaluate y prime. So now 2, I substitute x with 1 minus 2 e1. Okay, sorry, e2 plus e2. So finally, I have 2 minus 3e2. So settled. Now, differentiate respect to the following. Okay, if you look at the left-hand side and the right-hand side, are they same? No. Although if you look at the right hand side, okay, the right hand side over here, maybe you say that this is power of 2, this is not power of 2. Okay, now even I put power of 2 here, the way to solve this question are totally different. Okay, so because this nx, when I rewrite, it will become ln x. Okay, I change to x squared, so it will be x squared plus x power of -1. So when I want to differentiate is m prime x, I push this one in front, -1 ln x was the power of 2 plus x minus 2. Differentiate ln x squared, actually I put here ln x squared actually is 2 ln x. So I'm going to have 2 over x. Okay, correct, right? Okay, so differentiate 2 ln x equals to 2 1 over x. So 2 over x and plus 1. So if I want to make it look nicer, my thing will become 1 plus minus, okay, minus 1 minus 2 over x multiplied with 1 over ln x squared plus x power of 2. So how about this one? This one actually is only this side of this question. So this one, ln, first thing, x squared plus x. Okay, this is why I go underground. Okay, after that, this one is 2x plus 1. Okay, if you see that is why the question looks so different, you need to remember that is, if you look at here, this one, the ln bracket the x squared plus x. But this one, actually, the ln is only for the x squared only. Now, this question, x plus 1, x minus 1, no need to think much. My u is x plus 1. My v is x minus 1. So u prime equals to 1. V prime equals to 1. So I'm going to use the formula of differentiation of u over v. So v squared vu prime minus uv prime. So what is my v? X minus 1 square. So x minus 1 multiplied u prime is 1. Then minus uv prime is x plus 1. So finally I have -2 x minus 1 square. Then how about this question? Okay, this question, maybe some of you will just think that is, why don't we multiply it? Okay, if you multiply in, we have a t4 minus t squared and we have a t et. And then this one still need to use product rule. So regardless whether you multiply or you expand this this phrase, or you keep it as an UV, both are the similar, that is you need to use the product rule. So instead of that, so I'm lazy to expand it. So I will use my u as a my t, my v as a t squared plus t plus et. So my u prime equals to 1. My v prime is 3t squared plus 1 plus et. So my dA over dt, why is not x? Because this one is a t, so this one should be changed it to become x. So dA dt equals to uv prime plus v u prime. So my uv actually is t, 3t squared, sorry, 3t plus 1 plus et, and then plus vu prime is t cubed plus t plus et. Okay, if you want, you can expand this one, 3t cubed plus t plus t et plus t cubed plus t plus et, and finally you have 4t3 plus 2t plus t et and plus et. How about this one? We need to differentiate respect to u. Okay, now, if you look at this question, it seems that it's so complicated because you have an exponent, you have an n, and then you have a u at the denominator. But the thing is, if you look it properly, E7 actually is a number, Ln2 is a number. So the numerator for this phrase actually is a constant. So when I want to f prime u, what I need to do is I just bring my u up. So I will be having E7 plus Ln2 plus 1 multiplied by u minus 1 minus 1. So this is my Fu. So my F prime u will become this one, copy back because this one is a coefficient. And then I have a minus u minus 2. Differentiate constant is 0. So this one is your final answer. There. Okay, how about this question? Nothing much. We just change the square root, become 1 over 2. So g prime x equals to 1 over 2 x cubed plus 2x plus 1. This one becomes negative half. Differentiate inside is 3x squared plus 2. So that's all. Then for each problem, use implicit differentiation and to find dy dx in terms of x and y. Okay, this question is already clearly stated. You must use implicit. You must use the implicit differentiation. You are not allowed to use the explicit way. So what we do, we no need to think much. So means that you cannot rearrange this question. So this one is u, this one is v. So my u is negative 3x. My v is y. So u prime equals to negative 3. My v prime equals to dy dx. So now the left hand side is 15 x squared equals to, okay, uv prime, so negative 3 x dy dx minus 3y, and then 2 will become a constant, disappear, and don't forget to rearrange back. Dy dx equals to negative 15x squared minus 3y. Okay, then finally dy dx, okay, this one is a positive, so it's negative 15x squared minus 3y divided by 3x, and we cancel off we simplify the 3, so we have the negative 5x squared minus y over x. This also the same thing. They ask you to use the implicit differentiation for this question. So the left hand side is very simple. It's 6x squared equals to, this one bring down to 3xy plus 1. Power of 2 minus 1 is minus 1. And I need to differentiate inside. Okay, x equals to 3x. My y equals to, my u equals to 3x, my v equals to y. So u prime equals to 3, v prime equals to dy dx. So over here is 3x dy dx plus 3y. So finally, I need to rearrange everything. Okay, so if I need to rearrange everything because they asked me to find for dy dx, so what I need to do, I bring this one down first. So I have 3x dy dx plus 3y. I will have 6x squared divided by 2, 3xy plus 1. So this one cancel off and this one can cancel off. So my x dy dx equals to x squared over 3xy plus 1 minus y. And lastly is dy dx equals to 1 over x squared over 3xy plus 1 minus y. Okay, now this one over here, they are testing on your differentiation. But from now on, this below actually is testing on your algebraic manipulation. So if you can't get the below denominator, the few step behind here means that you lack of the ability to do the algebraic manipulation. So what you need to do is you need to have some more practice on how to simplify the xy, how to move the xy to the left hand side or the right hand side. Now, for this one, also the same by using implicit differentiation. But the thing is, although it's an implicit differentiation, I still can using the logarithm rule. So I have 3x squared plus 3 equals to ln 5 plus ln x plus 2 ln y. I use the logarithm rule, so I no need to use the product rule. Okay, so differentiate. This one is 6x, 3 is 0, so this one ln 5 is 0, so this is 1 over x plus 2y dy dx. And then finally, I need to rearrange dy dx equals to y over 2 6x minus 1 over x. Then how about this one? Also using implicit. So this one, you have no way to separate them. So what you need to do is, one thing, you can make it to become square. Bring it to the other side. If not, we just let our u equals to x or u equals to 1 over 2. Okay, and our v actually is y 1 over 2. So v prime 1 over 2 y 1 over 2 dy dx. And then u prime equals to 1 over 2 x negative 1 over 2. So my left hand side will become uv prime and vu prime. So I will have 1 over 2 x 1 over 2 y negative 1 over 2 dy dx plus 1 over 2 x negative 1 over 2 y 1 over 2, and then equals to 1 plus 3 dy dx. It kind of very messy because of the power of 1 over 2, but what you need to do, just be a slightly be patient. So now this dy dx and this dy dx, we can rearrange them back. So 1 over 2 x negative 1 over 2 y over 2 minus 1, I shifted here. This one I shifted to the other side. So dy dx my 3 minus 1 over 2 x 1 over 2 y negative 1 over 2. And finally, this one shifted to the other side, become a over b. And then now we have this question. y equals to negative x squared, find the second derivative. So what we need to do is just what we do. Okay, y equals to negative x squared. So dy dx equals to negative 2x, and differentiate second time, dy dx squared equals to negative 2. So how about this one? Fx equals to 4x cubed. So my f prime first derivative, I bring it down, is 12x squared. And then I differentiate second time, I have a 24x. So now this one is looking for the third derivation. So they already nicely put the index as negative. So the first derivation is negative 6x squared plus 12x minus 4. And then second derivative, negative 12x minus 48, x minus 5. And then the last one derivation over here, the third derivation is negative 12 and minus 48 multiplied by 5, and then x minus 6. If you notice here, that is, if the power of your x is positive and then the power is keep on reducing, and but the thing is, when your power is negative, the power is more negative, remember, because of this one is a when you derivation, you always minus 1. Okay, so now we have ended here for our chapter 6. Thank you.